Hey guys, today we are going to start reviewing a little bit of the laws of exponents so we can continue on with the logarithms unit. So we're going to review how to use the laws of exponents to simplify expressions. So there's a lot of different rules that we're going to go over, but a lot of them are very intuitive. The first one is the zero power. Anything to the zero power is always going to equal to 1, no matter what it is. Even if they put like smiley face to the zero power, it's going to be 1. I always think about this as if I have all my friends bailed on my restaurant reservation, I'm not going to go to the hostess and be like, hey, I need a table for 0. No, I still am sitting at that table. I need a table for 1. The other thing that you can think about is if you had x to the 7 over x to the 7, remember that would be 7x's on the top, 7x's on the bottom. That doesn't equal to 0. That would cancel out and give you 1. Okay, so anything to the zero power equals to 1. Pretty straightforward. The next type of exponent rule that you talked about probably back in Algebra 1 was negative exponents. And whenever you have a negative exponent, you always are going to make these things into reciprocals. So in order to change the sign on this, we can't leave a negative exponent. We have to cross the fraction line and take the reciprocal. So x to the negative n is the same thing as 1 over x to the positive n. Okay, same deal if it was down in the bottom, like this guy. In order for me to make this exponent positive, I need to move it and flip-flop the whole fraction and make that x to the n, and then technically over 1. Okay, so it's reciprocal. You're only flipping, though, the part that has a negative exponent. So if I look at this example, and I have 3 times x to the negative 2, you're going to notice that only the x has a negative 2 attached to it. If it looked like this guy, oops, in parentheses, that would mean that I could move this entire expression down to the bottom. But because this 3 doesn't have a negative exponent, he stays. So I always start by just drawing my line if I see negatives. And I'm like, does 3 have a negative exponent? No, he stays. Does x have a negative exponent? Yes, he needs to move. And then his exponent can become positive. Okay, same deal down here in the second example. So I'd have 1 over negative 3x to the negative 2. Now the thing to note here is this is just a negative 3. The 3 doesn't have a negative exponent, so it's going to hang out and stay there. So again, I see a negative exponent, I draw a line, I check each of my pieces. So 1 doesn't have a negative exponent, negative 3 doesn't have a negative exponent, x does have a negative exponent, so he moves up into the numerator. And again, you could rewrite this as x over negative 3 or negative x squared over 3, however you needed to rewrite that. Okay, so that's negative exponents. The next law of exponent you may remember is when you have a product, when you're timesing two things together with the same base. Okay, you have to have the same base in order for this law to work. So if you have the same base, they're both x's, they're both y's, they're both whatever, you can just add your exponents, which makes sense because if I had x squared times x cubed, that means there's 2 x's here and 3 x's here, so altogether there are 5 x's, so 2 plus 3 is 5. So when I look at an example question, we have x squared, y cubed, x to the 8, y to the negative 1. So again, I find things with like bases. So I have x here and x here. Those are the two that I get to keep, or that I get to use my rule on. So I would keep my base, it's x, and then I add up the exponent. So it'd be 2 plus 8 is 10. And again, you could list out all the x's and count them, and that's fine. Okay, then the second part of this is I look at my y's, because I still have y's together. And if you needed to, you could move this negative exponent down and then use a different law, but I know that if they have the same base, I write the base and then I add the exponents. So I'd have 3 plus negative 1, or just squared. So that would be my final answer. Okay, kind of interesting is that with addition goes, or sorry, multiplication goes with addition, where the division goes with subtraction. So again, you have to have the same base for this to work, and then they're being divided. You keep your base and you subtract your exponents. And again, you could do any type of example on this one. If you were like, hey, I had x squared over x cubed, hey, well, if I list this out, x times x on the top, x times x times x on the bottom, these guys all cancel, and I'm just left with 1x on the bottom. So then I would leave this as 1 over x, or x to the negative 1, so 2 minus 3 is negative 1. So if I do this example over here, again, you can only take your same bases, so I'm going to deal with these guys first. So I have x to the 7 over x to the 3. So that means that I would have 4 x's left over, and they'd be in the top. They'd have a positive exponent. Okay, similarly, if I took these second things over here, y to the third and y to the 11th, if I subtract those exponents, I would get y to the negative 8. And I know that I have to flip-flop anything with a negative exponent. So if you think about it, if you have a bigger exponent on the bottom, that's where your thing is going to stay. So if I looked here, I had a bigger exponent on my x in the top, so my x has got to stay in the top. I had a bigger exponent on my y in the bottom here, so I got to put my y's in the bottom. And if you had made this x to the 4, y to the negative 8, that's fine. You just have one extra step in the end to think about. Okay, so those are our product and quotients. Now we have some that deal with powers. Right here, when I have anything with power raised to a power, you are going to multiply your exponents. And what that reminds me of is I have 2 letters next to each other with no symbol in between, and they're right next to each other, so it kind of looks like multiplication. So you're going to do x to the m times n. Okay, and again, this makes sense. If I listed this out, there would be 3 of these things in parentheses. So I'd have x squared times x squared times x squared. And we just talked about what that rule was. I keep the base and I add the exponent, so 2 plus 2 plus 2 is 6. Multiplication is just repeated addition. Okay, so right here, x times 2 to the 3, or x to the 2 times 3 is just 6. So multiply your exponents together. Okay, now this one is the one that's really tricky, this guy, because we've always been told that we can't do this. We can't say x plus y squared is equal to x squared plus y squared, because that doesn't distribute, that doesn't get me that xy term in the middle. That only gives you 2 terms. However, exponents do distribute over multiplication. So this is kind of like a distribution property. You are allowed to give every piece in here an n power. Okay, and that makes sense again, because if you wrote out all of the terms inside, like if I had xy squared, that would be x times y times x times y. So there's 2 x's and 2 y's. So I'm just basically distributing my exponent. So if I look at this example here, again, you can list out all these 2xy squareds, that's fine, or you can know that you get to distribute this cube to everything inside. The hardest part to remember here is you do have to distribute the cube to the big number, to the coefficient. Okay, so I'd have 2 cubed, x cubed, and y squared cubed. And you can skip this step if you already know what to do here. We'd have 2 cubed is 8, and a power raised to a power is you multiply your exponents together. So that would be your final answer. Okay, this is another property that likes to trip people up. We remember that when we have a negative exponent, it flip-flops stuff. And also, we know that we would distribute things inside those parentheses. So there's actually 2 ways we can write this. We could rewrite this property as y over x to the positive n, because that would be me flip-flopping whatever was inside and then keeping that power. Or I could also rewrite this as y to the n over x to the n, because that's going to distribute, kind of, the exponent distributes inside through that division. So if I had a problem like this guy, what I always do first on this is I like to flip it first, because if I flip it around first, then I dealt with this negative exponent. I don't have to play with that game anymore. So in order to get rid of my negative exponent, I'm just going to flip-flop every single piece inside here. So I'd have 2y squared over 4x cubed, and then this is now all to the 3rd power. Now this makes it a lot easier because I can just go ahead, let me get purple, and distribute to each piece inside. So I'd have 2 cubed, which is 8. Y squared cubed is y to the 6th. 4 cubed is 64. And x cubed cubed would be x to the 9th, because you multiply the exponents. Now I just try to simplify if I can. I know both of these are going to divide by 8. And so my final answer would be 1y to the 6th over 8x to the 9th. Okay, just a couple more properties. This one is the one that probably gets confused the most, because you mix up the rational or fraction exponents with the negative power. So this guy, if you have a fraction exponent, I always think of something called flower power, and I forgot to get a clip art picture, so I'm going to draw you a picture, and you're going to make fun of me tomorrow, but it's okay. So if I have a flower, we all know what a flower looks like, not very much like that. Then I have the ground that it's sitting on, and then it has its roots underneath the dirt. So if I think about this, this is almost exactly like my fraction exponent. I have my flour on the top, which rhymes with power. I have my dirt line, which is like my fraction bar. I should have wrote that smaller. And then on the bottom, I have my roots, or just my root. So if I look at this thing, anything on top of the fraction bar is going to be your power. Anything underneath the fraction is going to be the root. And so when you write this out, you would take this and you would have this say, x is still your thing, your base. Then your root goes outside in here. Remember, there's always an implied 2 if there's nothing there. And then your power goes on the inside. Okay, and there's a couple ways you could write this as well. You could take this and you could take the nth root of x and raise it all to the m power, or you could raise x to the m power and then take the nth root. Okay, so let's do a couple examples. If you had x to the 1/2, if you have a fraction exponent, that means that you have a root. So I always automatically write my root in. Figure out what my base is. My base is x. My power is 1, and my root is 2. So I could technically put a 2 there, but I'm not required to because that is already implied with the square root sign. So anything to the 1/2 power is just the square root. Okay, when you start getting into things like this guy, you just go ahead and again, I see a fraction exponent, I draw my radical. I'm going to put my base inside, which is 4. The power is on top, and then my root is a square root. And so again, there's 2 ways to do this. You could take 4 to the 5th and then take that square root, but I have no idea what 4 to the 5th is. So what I'm going to do is take the square root of 4 and raise it to the 5. So 2 is a square root of 4. Raised to the 5 is a lot easier because that's just 2 times 2 times 2 times 2 times 2. I think I said that 5 times, which is 32. Okay, so if they're all numbers, you can simplify down. And one of our last misconceptions, or maybe not misconceptions, just a reminder, is that if you ever have a square root of a fraction, you can always just do the root of the top over the root of the bottom. And that makes life a lot easier to try to simplify when you're just taking roots of pieces. So for instance, I had this expression, the cube root of -1 over 125. This would just be the cube root of -1 over the cube root of 125. And you are allowed to take a cube root of a negative number, because remember, a negative times a negative times a negative would still be a negative. So we ask ourselves, what is the cube root of -1? What times itself 3 times gets you -1? It's -1. And then the cube root of 125 is just 5. And just one little note about exponents as well, especially when you're plugging in the calculator, you have to be very, very careful how you type them in, because these two notations are two completely different things, especially using your calculator. So what's happening here on the second one, parentheses -7 squared, we are taking -7 and we're timesing it by itself twice, which gets me positive 49. Now if I did this first one, the negative's not actually being squared. This would be like saying -1 times 7 squared. So you're taking 7 squared, which is 49, and then you're just going to make it negative in the end. And those are two completely different answers. So if you're using your calculator, you need to be careful what you're typing in, and when you're actually squaring things, you need to be careful of what's actually getting squared or what's actually getting raised to the power. Okay, that's all I've got for you today. That's pretty much a review of all the exponent rules. Whew.